Hey, welcome back to the Builded Basement. Today we're starting our VORON 0.1 build from LDO. This is an LDO kit, so all the parts are provided by LDO. That includes the extrusions, the rails, the hardware, the motors, the steppers, and then they also provided inside that kit some tools, hot end, electronics, Raspberry Pi, etc., etc. Purchased my kit from KB3D, so a big shout out to them. No discounts, nothing like that. Just a good shout out to them because, well, every time I need something, they have it. And shipping's pretty quick, and they seem really nice to work with. So let's get in a little bit about Voron in general. If this is your first Voron build or your first video you've watched about Voron, or maybe your 50th. I want to talk a little bit about Voron in general. So let's shoot over to that real quick. So, Voron is an open source community of, well, folks like me and other people and you and some engineers and some people that are very smart, very good at what they do, and very good at 3D printers in general. But more so just such a mass of people that things just really happen quickly. I mean, modifications to make things better happen quickly. People come up with new things. It's generally just a really good platform to work with. They do have a couple different printers. They have the Zero, the Trident, the 2, the Switchwire, and the Legacy. And there are a kind of a subset within each of these for different tool heads and things like that. Different size machines and whatnot. But basically, vorondesign.com. You can go there and kind of read up about it. Like I said, today we're working on our Voron 0. And let's see if they have some pictures in here that we can look at real quick. Gallery. See anywhere where I can get more gallery stuff. But yeah, this is where you'd come. You get the STLs to print your own ABS parts for this. I do just use ABS. Do not use PLA or anything like that for these printers. You can get CAD for them. Everything is available on the Git. You can basically go in and see slicer profiles for printing your parts, things like that. You can go back in, you can see your firmware for your clipper, right here with an SKR Mini. You can also see some drawings and other things. Basically, really good way to go. And like I said before, KB3D, great place to get that type of thing if you're looking for it. There are tons of other places you can buy them. And frankly, if KB3D is out, not offending anybody by saying get it where you can. If you want this LDO kit, great place to start is KB3D. But if they don't have it, you know, try someplace else. Or you can self-source all your parts. Looks like currently they're all out of stock. Kit I purchased is blue, but they do have plethora of parts in here, so even if they don't have a kit, it might be a good place to come to get some of your parts. Like I said, really good for me. Another quick place I want to go here is Team FDM. A lot of good mod parts that aren't necessarily directly part of the Voron team or the Voron group, I guess. These drop-in nuts are very important. It's one of the things that people have the most trouble with. The Voron uses these little nuts that basically ride inside the rails as opposed to using T-nuts. And basically they'll move around quite a bit on you if you don't use something to hold those. These are kind of carriages for those nuts. So I do suggest that you strongly consider printing something like this. In actuality, if all you can print is PLA, because these are just temporarily holding these nuts while you assemble your printer, even if they loosen up or fail after you've assembled your printer, the nuts are really what holds everything together. So you could print these pretty much out of anything that is decent enough not to fall apart while you're actually putting things together. So, to the manual. All right, so this is the manual for the Voron 0. And contrary to belief, the 0.1 is not the first Voron printer. It's not the oldest. It is the smallest Voron printer. So if you're looking for a very small printer, something that doesn't take up a lot of room, something maybe you want to build a couple of and just have something small where you can print small objects, you know, whether they be trinkets or actual, you know, parts that can be used, engineering type parts, this will do it. But you got to maintain something that's pretty darn small. I forget what size the bed is, but I think it's something like 80 by 80, somewhere around there. I could check real quick, but I'm not going to. It's very small. So just like all the Voron manuals, what you start off with is an introduction. Sometimes these are pretty candid, but good luck. Let's see, what does this one say here? Oh, the Discord. So they mentioned Discord on here. That's another great place to get information. I do suggest you check out the Discord if you do need some information. A lot of helpful people in there. Sometimes I'm in there. Set up in channels, you go to the VORON 0, but in general, if you just do some reading through there, you kind of get an idea as to what people might see for issues before you build. It's also a good place to ask for mods if you want to do mods before you start your build. I do suggest that you build your kit or your BOM, your self-sourced kit directly to specifications and mod after, but you could do it whatever way you like. Table of contents, there you go. And some print guidelines. I'm going to go over this real quick. So this is an introduction to Voron. Infill percentages, materials, things like that. Well, we'll start here. So FDM, the reason I'm suggesting FDM is because of the type of material that you're going to use, which is ABS. Infill, so basically relatively strong infill in both, you know, or actually all three directions. That's why they're using a grid or a gyro or a honeycomb or triangle or cubic. But they don't want to see as lines or zigzag or something like that. That doesn't give you a full, you know, XYZ type strength to the material. Material ABS because of the way it is, the shrinking and the temperature ratings of it, the hardness of material. Everything here is designed based on using ABS. Can you use other materials? Yes. Will you have the same results? Maybe. There are some parts that may be better with a polycarbonate or a nylon. But for the most part, if you stick with ABS, you will be fine. You'll be good. Do not use PLA. Do not use PLA plus. Do not use PLA plus spelt out plus. Use an ABS material. You may be able to get away with an ABS plus or an ABS pseudo ABS material, we'll call it. But pure ABS is the best way to go. Infill percentage, they recommend 40%. I have a profile I use for all the Voron parts that I print. This and the 2.4 that I've already built. If you haven't seen that, go check it out and subscribe, right? So I use 50. They recommend 40% on this. You do want some relatively decent amount of infill in there. These parts are not for, you know, trinkets. These are parts that are going to hold up to some level of stress. Layer height 0.2, so pretty basic right there. Wall count recommended 4. Again, that's for rigidness and strength of the part when you print it. I go at 5. Doesn't make that much of a difference. It just keeps my solid top and bottom and my walls all the same. And then you're extruding with 0.4, which again, pretty basic. Little note here about print it forward. And that's pretty important. So print it forward, kind of like pay it forward, is a group of people that have offered and do offer to print parts for other Voron people if they want to build a Voron but can't print their own parts because they can't print ABS, or maybe they don't have a printer at all. I will tell you right away that the wait times for print it forward are long. So if you don't mind being out 4, 5, 6, maybe even 7 months to get your parts, it's a good way to go. If it was closer to 2 months, I'd say no doubt about it, just use it. But at, you know, like I said, 6 months, it's a hard pill to swallow. I would probably see or try to figure out a way to, you know, print your own parts. I do have some tips on printing ABS on an Ender. Ender printer you can get for a couple $100. So I do suggest you learn the materials. I also suggest this probably isn't your first 3D printer. I suggest you get something cheap, tinker with it, learn how it works, learn the ins and outs of it, and then maybe come over and start building something yourself. But print it forward. There you go. Discord. At first I didn't like Discord. It's a good name for it. I don't think it's as organized as I'd like to see it, but it works. GitHub. Probably familiar with GitHub. If you're not, it's basically a repository for programs, data in general, that people use, people update, gets maintained. It's a hub. And the Voron docs, which when we're looking at. So I did notice one thing about this manual that I didn't notice about some other manuals that are out for other Voron printers, and they go pretty in depth in the actual hardware. So right here, I'm gonna go through them really quickly. I do want to get into building this thing pretty quick here, but and this will be one of many videos, just so you know. They go over button head screws, your socket head screws, your hex nuts, your flathead countersinks, your pulleys, your lock nuts, your bearings, your heat certs, shims, self-tapping screws. They don't mention idlers in here, and honestly I haven't looked deep enough to see if there are any idlers, but I would assume there are some. But this is kind of a basis of parts that you'll use to put together a 3D printer in general, whether it be this one or another one. Let's see here. Blind joints. So basically a blind joint means a joint's put together that you can't see the screws once it's together. So things kind of slide together. You can kind of see it here. You're first going to insert the screw into the end of your extrusion. And this is an extrusion, in case you didn't know. And then basically you're going to leave enough room in there so you can slide the groove of the extrusion over that. And then basically what you're going to want, what your end goal here is to have this inserted over, have these two surfaces perfectly perpendicular and flat to each other. So getting things together pretty square is a plus and a must. But square across the top here, square and flat across this side, square and flat across that side, and then 90 degrees on your inside. So a perfect 90-degree corner. As perfect as you can get. There's kind of a cutaway showing you what it looks like when it's assembled. There's a cut through the center here, so you can put your X key through to tighten that up. I'm showing it right here. Then once that's tight, that should be a pretty good solid corner. So let's see what they say here. Students have to, yep. Small, yep. So basically, something you're going to have to do, something you have to learn. Pretty easy. Introduction about some tools, drivers. Skip over that. It's not much there. And then a reference on the actual extrusions. Okay. So this is kind of the beginning of the build. So I'm gonna go grab my extrusions. Oh, if you haven't, subscribe, right? Haha. Alright. So blue extrusions. And we'll grab that as well. What else do we need? Do I think? Let's see here. Looks like we're probably going to need to mark these. I'm going to grab good old masking tape. And Sharpie. These we'll have to cut these things a little bit, so cut the tape across them. So let's see here. And we're also gonna have to measure these too. Having a decent ruler, good to have. Nice square, good. And a pair of calipers is always a good thing to do too. You don't have to go out and spend hundreds of dollars. Just get yourself a decent caliper that you can zero out. Works pretty well. We'll leave that out. All right. Set that aside. Grab these rails out. So, as I go through this, I have not opened up all these parts and looked. I've opened them up a little bit and kind of looked at them, but I haven't done much with them. So, talk about them while I go through them. Kind of impressed here at the packaging. So it looks like they've gone ahead and they've put some foam around all of these. They are all 100% covered, so shouldn't be any scratches or anything on these. So let's go ahead and start cleaning these up. That is a very nice blue. I like that. Do that. Yeah, nice blue there. Huh? I like blue. Looks any different on that. Nice little bit of a metallic color on there. So nice blue. Put that in the box. Not a lot of gravity in these aluminum extrusions. Pretty light. Pretty small too. It's kind of gives you an idea as to how small we're talking about. Because the printer will not be much bigger than our largest extrusions. So just for funsies here. Just to perspectify that thing. There's a mouse. So, yeah, it's pretty small. But because it's small, that means your bed's going to heat up nice and quick. And you're going to be able to print with this at a pretty high speed. You know, your tolerances are going to be pretty decent, and the amount of mass you're swinging around while you're doing a print is going to be minimal. Pretty cool, right? Do like this blue. So as I do this, I will mention I do have a complete build of a VORON 2.4 series of videos. Those were the first videos I've ever done. This is my second VORON build and some videos away from where I first started. So if you do go back and look at those, pardon the quality, pardon the experience. In actuality, it's been a while since I've done any video, so pardon this video too. So do what I can about building printers, not about making flashy videos. But yeah. So let me see what we're working with here. So 200 millimeters. In case you know everything's in millimeters. I hope you would know that, but maybe not. Yeah, it looks like the majority of these are 200 millimeters. Yeah. So there are 12 200 millimeter extrusions there and 3 smaller extrusions. That makes sense. All right, so there's A, B, C, and D. So what are the differences? Well, looks like all of ours are tapped on the ends, on both ends. So that's the same. So I don't see any particular differences between A and B. Let me grab an M3 screw real quick. 2, 3, I'll do it in 2x16. There you go. Make sure these are all tapped the way I think they are. 3 by 16. That's an M3. 3. 3. 3. All right. So it looks like there's only one in here that they don't show being tapped. So I think what they probably did is they went ahead and tapped all of them and threaded them all, just because it doesn't make sense not to when they're machining these. Sometimes it's easier just to do everything than do all but one, even in quantity, just for manufacturing quickness. So the other thing I'm looking at now between these are some holes in them. It looks like some have holes in the sides and some do not. So let's zoom in a little bit on that. So there's a hole in that one. No holes in that one. This is a better camera. Yeah, there we go. So, try to make this out here. So yeah, so hole in this one. See that? No holes in this one. Put that aside. So we got a holy area and a non-holy area. We'll adjust that a little bit. There we go. Stop shaking. There you go. All right. Another one with holes in it. Put that in our hole pile. Non-hold. That one has holes, but they're different. So make a mental note of that. Hole one. Non-hold. Hole one. They're hold one. They're differently hold one. So the differently hold ones I'm seeing here. And we'll get back to the document here in a second, but basically the holes are a lot further down than these other ones. So they're easy to spot. Let's see here, another one of these. These. One of these. And another non. We have our smaller ones. And we don't really need our ruler. Alright, so as of current, I have 4 different piles. Let's see where we should be. Alright, so it looks like one is, or A, non-tap, 200 millimeter. Okay. We decided that they're all tapped, so it doesn't matter. And then 5 that are tapped. So I have a total of 6. 5 plus 1 equals 6. So that would be those ones right there. What I'm going to do, just to mark these. You know what? I don't really need to mark these. How many actual different types are there? You know, I'm not going to mark these. I don't think I need to. This isn't that complicated. If I was going to mark them, just helpful tip. What I would do is basically take your take your masking tape, put a strip across it, rip it off, and then basically label them, you know, A, B, B, whatever they are. And then take a razor blade and just simply go click, 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 click. And then basically you have a mark on each of them without having to sit there and do little pieces of tape, because that's a huge waste of time. All right, so back to this screen. So we have our A and B. Now I'm just going to put them in alphabetical order. A and B, they're both the same. No differences in this kit. And then our C, which have, see what we have here. We have extrusion, and then a 2 with, okay, 2 that have them on 2 different sides. Find that. At least that's what that looks like. Let's see here. Might be misreading that. So 2. I think 2 that are C, that 7.5 millimeter in. On both ends. And then 7.5 millimeter on one side. All right, we'll come back to that in a second. We know we have these. These are 29.5. Just to look at that real quick. Yep. Pretty close right there. So that's those ones. There wasn't much of a doubt on that, but all right, so that's our E. So AB is going to be our E right there. And then F is no. Let's see, F is no holes on either plane, and all of mine have holes. So the 3 we have, they can all be either F or G. Again, makes things a little bit easier, both from the manufacturing standpoint and from the assembly standpoint. And then this is H. How is H different than A? Quantity 2 of H. So H has, so I mean H, what's the difference between H? Between H and C, 200, 200, 7.5, 7.5. Okay. I see no difference between H and C. Maybe I'm missing something. So 2 C's, 2 H's. Okay. Yeah. I'm looking for ones that don't have additional holes in them. So those 2, that and that gives me 4. So that's H, and that's also the same as C. So I'm gonna put 2 there, 2 there. So that leaves me with these 2 guys. So, okay, there we go. Yeah. So, we're 100%. So we get these 2 guys that do have holes on that. And then they also have holes there. So basically they're double holed. They're holed on both planes, which is D. Right. So D, then E. All right. Nice. So A, B, C, D, E, yep, F, and G. They're the same. We're all hold. And then H, which H is the same as are C's. Not quite sure whether there's a separation between H and C. Odd. All right, so there it is, the frame. Cool. So if you're not familiar with how I do my videos, I usually go pretty in-depth, step by step, piece by piece. So this video, as well as my other videos, will be quite long. Do feel free to jump around if you need to, or even jump around between videos. I don't make them quick. It's real time. Some of the videos may be live streamed. It all depends on what you guys leave for comments down below. And yeah, so let's get back to that frame. All right. Oh, let's see here. Component prep. All right, so here's something we haven't seen yet. And if you're, a first time printer builder, or have never worked with heat inserts or heat certs, or heat set inserts, I usually call them heat certs. This is something you're going to find used quite often on Voron printers. So our component prep here with our first piece. What does it say here? Design relies heavily on heat set inserts. Make sure you get proper inserts. Check the hardware reference. Too close to the picture. You've never worked with heat set inserts, or recommend you watch a guide. I have a guide. There's tons of other ones. Nero has tons of guides. Just about anybody in this circle has guides. There's not much to them, but we'll do one, and you'll see it. I'll be doing a bunch, so let me find that piece real quick, and let's see here. Things. So you guys can see what I like to do with my setups. Is I usually set out my pieces in these bins. These are my printed pieces right here. Kind of roughly in the order that I'll be using them. On all Voron printers, or as far as I know, all Voron printers, you have your primary pieces. Then you have pieces that are designated as accent pieces that you can print off in an accent color. There is a Voron red. I prefer a blue, but I figured I showed you that. And hit parts over here on this bench, so I got everything over here to work with when I need it. All right, let me see here. We need that, and if I grab this box, that's my screw. Put that over there so I don't get confused. Camera cords, LDO sticker. So the part they want us to use, I believe, is this guy right here. And one thing you're gonna get used to doing is basically figure out your orientation of your parts. I know sometimes these are a little hard to come out because they aren't black, but the orientation is important when you're doing these. So there's that. This looks similar but is not the same, so I'm gonna actually put that back away. And we're gonna open up our box of parts. So there should be a package in here. Oops. Parts here, little tiny cute little rubber feet. They're adorable. Look at those little guys. Those are the rubber feet. So there's my finger. It's actually about the same size as my pinky. Fun. All right. So let's see if we can find those. This. A couple T-nuts. Throw that back in the box. And cut open. Try not to cut yourself. Right. Fun stuff. Those. some other things. Yeah. At this point, I'm going to take these. I'm going to put them in one of my bins. And at some point, I'll separate those out so that they're all separate. I'm not going to do it right now, though. Okay. So basically, what you're looking at here is our first two heat certs. So that's the way I can do this. Let's go back to the bench. And I'm going to turn on my soldering iron with... There's a couple different ways to do this. What I have on this right now is a tip for installing these things, but you do not need one of these tips. This basically just allows you to adjust the distance, but it's just as easy and works just as well for the most part to take a soldering tip from your soldering iron and file, shave off, or cut and sand off the very end of it, because what you don't want is to push into the plastic on the end to make fumes and possibly degrade your part a little bit. So in terms of temperature, I like to stay well below the temperature you print at. So I'm going to be at about, this particular plastic I print at 250. This is Amazon Basics Black. I'll have a link down below in my description. But I'm going to stay 30 degrees Celsius below what my print temperature was. I don't want it to melt quickly. I want this to kind of work its way right into there and get into the little grooves and stuff in there. We'll look at this a little more closely here in a second. So we're gonna need 2 of these to start off with. Most of these kits come with just the right amount of parts, maybe a couple extra, so be careful not to lose a bunch. It's called your fault, not a their fault thing if you do lose them. All right. So it's in on there. So what you have basically is on the inside there, you have a thread. It could be an M3, an M5. A lot of them are M3. And then you have kind of like a knurling there on the outside, and it's going in 2 different directions. That way when it will grab whether you're going in or out of the piece that you're screwing into. So back to the screen thing, and we'll bring this up. So I want to orient my piece as closely as possible to the way they have it on the screen. And I also want to attempt to put my piece down flat. So I want to find what holes I need. In this case, I know that it's going to be these 2 right here. And then a note on that, when you do insert these, there is a smaller end and a larger end. The smaller end will go in, and it should just barely fit in, but not fall in if your print is decent. So it should kind of hold itself in place. Do that one. And now my soldering iron's all ready to go. The only real trick to this is making sure you keep your soldering iron as close to 90 degrees as possible from what you're doing. If you go at an angle, your certs will go at an angle, and your screws will try to go in straight, so you could cross thread, things like that. But we're dealing with plastic, so it's pretty malleable. So it's going in slowly, which is what we want. We don't want to suck right in there quick. And what I'm looking to do here is get it so it's just below the surface of the plastic I'm working on. You don't want to stick up proud of the surface, and you don't want to be too much below the surface. So when you look at it from the side, you shouldn't see them sticking up. But but also they shouldn't be all the way down. They shouldn't be much further than below the surface. You know, sheet of paper. All right. So we did that. And then there's a note here about a chain and attaching it to that part. So I guess I need to find the chain real quick. Parts. Where would they have hid the chain? Nope, chain's not in there. Helping. That's odd. If we go float this chain. Worried for a second there. Could not find the chain. So this is our drag chain. That's where our electronics are gonna go through. This will hold them together. This particular drag chain does not come apart, but this length is short enough that it shouldn't make that much of a difference. A lot of drag chains will come apart. There'll be a little portion of them right on the side here that you can clip into and then kind of snap them out, and they'll open up. You open up the whole length of the drag chain, run your wire inside of it, and then close them all up. But that's if you got a drag chain that may be 3-4 times the size of this one. So what they're looking for us to do, again, keep an eye and be aware of, direction of the part that you're working on. They're looking for us to remove an end link. So that's kind of interesting. Tell you why in a second. So my drag chain, this isn't the first time I've ever seen this, but my drag chain doesn't seem to bend the same way that they show theirs. So let me show you that real quick. So my drag chain right here bends this way. And according to the picture, these angled pieces are heading the other direction. But here's the thing, on these drag chain ends, these can snap out and they can snap back in. You can flip them around. So don't worry about that if your drag chain looks like it's backwards. You may have to flip it around. Either way, we need to take one of these ends off like that. And when you do that, there are a couple nubs on these. They do have a filing or a bevel on them in one direction. And basically these relatively easily can push over and slide onto those. You should try doing both at the same time. You can give this a little bit of a squeeze when you're doing it, and they'll go on there. But these come apart pretty easily. And the rest of this will come apart too if you need to. If you need to shorten up your chain, a lot of times you may have to shorten up a chain a little bit. Or if you have additional pieces and you want to make your chain longer, you can do that as well. So, all right. So we did that. Now we need M3 by 8. Okay, so let's look at this real quick. We need M3 by 8 BHCS. So this B right here stands for button. Well, the BH stands for button head. So what we're looking for is a screw that has a round top to it with a bevel on it, as opposed to one that looks more like a flat-sided unit. This is 100% beveled. So let me find our M3 by 8 nuts real quick. A lot of these VORON builds, they use a lot of M3 screws, some M5s, 5s. You only need 2 of these. that. And I'm going to use my Dremel. Different bits. I don't know where my little bits went. All right. Maybe we're not using Dremel right now. Set that aside. Allen key wrench. And basically, we will attach that the way they show in the picture. So orientation being what it is. That. And use our screws. That in there. Not going to tighten it up just yet. And that button head screw is round on the top. A button. Try to line that up nice and flat. Further. All right. So it's flat on the table. And I'm just going to give it a little bit of a tight. Do keep in mind we're working with plastic here. So even if we are using heat certs, those heat certs are in plastic and we're connecting plastic. So our connections only need to be as strong as the plastic we're connecting to. So there we go. All right, so that is done. All right, nut adapter strips. All right, so as part of the files that they provide to you, there is an STL file for printing those. Right here. So you can print these out. This is an ABS print of what they give you, and eventually these are gonna, slide in to your extrusions. But in the LDO kit, I believe they provide. Find them. Here. I believe they provide. Yep. Metal slides. So these allow you to forego printing off those parts and then inserting your nuts. These are already threaded inside of them. They're already spaced properly for what you need. So makes it a little bit easier. Get you to save a step, right? And these normally take M2 nuts. So if you were printing your own, basically, you'd have your piece like that. Then have your M2 nuts. These guys are small. And then basically you'd be inserting your M2 nuts into those like that. And that kind of would hold it while you're building your printer. And then these would get slid inside the rails. Like so. and that'd be your attachment point to that M2 nut. These, you forego the printing and inserting nuts, and they go directly in, and they're already spaced and everything. So a little bit of a helpful thing from LDO. You can buy these separately too. I don't know if they're on the bill of materials yet, or if they ever will be, but somebody's manufacturing them, so I imagine that's a better way to go. That's the way we're gonna go because we have them in our kit. So back to our screen. So we can not populate these. And let's see here. So they are showing you basically that you're putting them in 1, skip 2, 1, skip 1, and then skip 1, skip 1, skip 1. So you're not putting them in every single hole. It's kind of nice to show here with them inserted. 1, skip 2, 1, skip 1, 1, skip 1, 1, skip 1, 1. So in case you're doing that, there you go. So they want us to use our E extrusions. And our E extrusions, see, A, B, C, D, E. So our E extrusions are these ones. 4 of them. And we're going to be using our MG N7 rails on those. And then we're going to be using M2 by 6 button head screws. Okay. So A, B, C, D, E. These are E's. So we need 2 of these. And then I'm looking at the pictures. And if you look closely at the picture up here, you can see there's a hole right in that area. So you want to make sure that when you align these, that you do that the same way. Again, you want to try to keep everything the way it's shown in the picture. So these are going to get split in. Set these on the side. Turn off my soldering iron for now, I guess. And the rails, and then yeah. So on here, there's a picture of this little doohickey. It looks like, you know, old school Yugo, something maybe from Space Invaders. That's a center rail installation guide. So basically that snaps over the rail, and your extrusion, and then your rail is basically in the middle of that, and that basically has equal spacing on either side so that you don't have to sit there and try and fiddle with it. So those are part of your print or your pre-print. So you're going to want to print those off. Make sure you print those off. You're going to need them. It's going to make your day a little bit easier. So grab those here. And then we're going to need M2 screws. M2 screw. M2 by 6 button head screw. Button head screw there. And rails we have right here. So let's see, look at the rails real quick. I believe all the rails are the same size, but double check here. Yep. All the same size. So we're gonna need 2. So you can grab any 2. And talk about this for a second. That was weird. That one's not. Where's my razor? That. Right, set that aside. 2 rails. So these are linear rails. Linear in the sense that they move on a linear motion. Rails in the sense that they're rails. These doohickeys that are in them are to stop the rails from flying off completely. If they do, The little ball bearings are in there, could slide out, and you're never going to find them all. You can try. Probably make a viral video. You're trying to pick up 60 little ball bearings. Maybe with a magnet. I don't know. These glide pretty well. They're clean. Back in the day, from what I understand, before I was building printers, you had to clean these out with either isopropyl or some type of cleaner of some sort to get rid of the grease and the grime that's inside of them. But they've gotten a lot better. And the best way that I've seen to actually add some lubrication to these, which you should, is use the back holes on these. Now for lubrication, here's what I suggest. You go on Amazon and you find yourself some blunt syringes. And basically, these are syringes that be really painful if you actually try to inject something with one. And they come in different size tips. And the largest tip that you can use is what I would suggest you use when you're using these, because the material we're using isn't all that liquid. So do that. And then for lubrication, I suggest use something with PTFE. I got Super Lube. I've got Super Lube. I've got this Motorcraft. I also have some Clear Gold by Tribology Tech Lube. Anyways, I'm just gonna go with the Super Lube. Pretty readily available. I'm just gonna fill up my syringe a little bit. Don't need a ton. The air out. Comes out the end just a little bit. Like I said, this does not push all that. Oh, there we go. Easy. Grab myself a paper towel. Put away the big tube. And then I am simply going to line up the carriage over one of these holes. Two of these holes as it would be. I'm going to inject lubrication right in there. I start to see it come out the little hole. To do that, I'm going to move back and forth. Going to get on and in everything. It'll look a little messy, but it's grease. What do you expect? Wipe it up a little bit if you like. And this PTFE grease is safe on plastics, as it is on metals. So, good way to go. Second one. That. Move it back and forth, let everything work together. And you can do this down the road, but think about what we're just doing right now. Think about how these mount. These mount on the surface like that. So these holes that we just used, we're never going to get to those again without taking this rail completely off. So now's a great time to really fill that up with grease. You know, in the future, you can use, there are grease holes on these on the ends, but a little bit hard to get to, and not all carriages have those. So be mindful of that as well. Clean up that tip. I think the package I got came with it came with little covers. I'll put a link down below for this too. Based on the size of the tip. Big. I was using the biggest tip. That'll work. So there we go. Ready to go, and there's probably enough lube in there to lube 25, 35 rails. So what you can do at that point is use a magic marker, right on it. ETFE lube. ETFE lube. There we go. That aside for now. All right, back to our screen. All right, so now we're going to mount these things to the rails. So again, we want them how they have them. So just keep doing that. And then we're going to basically put these on this like this. So I'll show this up close. Our insert here for our print is roughly the same size as the rail, and that's because we're using the screw holes on the very end. So our screw holes on the very ends line up with the very end of that. The only difference is on this rail, there's a little bit more meat on the end. So, and then what we're going to do is place that on like that. I'm going to grab a little magnet. A little trick I had in my last videos or series of videos I like to have on the bench is to keep a magnet on the bench, because these little screws can get away from you pretty quick. So you have a little magnet on your bench, they stick to that, you're pretty good. So we'll do that. And you got to get an key for that. Let's see if this is the right size. Yep. So let's see. 2x6. I'll line up our first hole. Drop this guy right in. I'm going to give a couple spins. Make sure it's catching. Yep. And I'm not going to over tighten that whatsoever. Not even going to tighten up very much at all, because right now all we're looking to do is get a couple screws in it so it's in place. It's physically attached to that part below, but that's about it. So we got that one, we get that one. We got to skip one over. Maybe one in this one. And then we're going to need one in that greasy hole right there. There, yep. And then it looks like there's going to be one more in there. What we'll do is one's in there a little bit. What were they showing again on this? Let me see. So they showed us 1, skip 2, 1, skip 2, 3. All right. So we got 1 here. We're going to skip 2, and then put 1 here, and then it's every other one, just like they show us. Oh, this one isn't lining up. Why not? Oh, I see. Okay. Like my rail is in there backwards, possibly. Weird. I thought these look like they... Nope, they're not. Okay. So, mistake made there. My backer is in backwards. Take that back out. The one thing to say here when you're building one of these printers is to make sure that if you catch yourself with a mistake, You don't ignore it. It's not going to go away. It's going to catch up with you. It's going to cause you headaches down the road. That headache could be when you start printing, or that headache could be when you get to the next step. But at some point, it's going to cause you a headache. So, if you got a mistake, fix it. Do what you're supposed to do. Make things go a lot smoother. Is that one? And where's that one? Okay. What was happening here is come on. I had that one, then that one, and over here I had that one. Skip two. All right, so pull this out, flap it around. That again. Hopefully that lines better up with what we need. Let's see here. So as you can see in this drawing, see they show the hole right here, but they're not showing it in this right here. So it's one of those little things that you kind of catch, and you got to try to make sure you keep an eye on. Here's the odd thing. All right, maybe I didn't make a mistake. It doesn't look like, I don't know how important it is at this point, but it doesn't look like any way that I do this, that these rails are going to allow, or these backers are going to allow me to do what the rail or what the instructions want me to do, which is 1, skip 2, 1 here, and then every other one. They want me to do 1, skip 1, 1, skip 1, 1, skip 1, 1, skip 1, 1, skip 1. They want me to skip 2 right here, or put 1 there, do 2 in the center. Okay. So because of what we have here with this backer is a different pattern, I'm going to go with the pattern they have on these, which may be 1 additional screw. That's fine, I guess, right? As long as you have enough screws. That's a whole nother story. If you do build printers or a printer, I do suggest that you invest a few bucks and get yourself some additional parts. You may not need them in the beginning, you may not need them in the end, but at some point you will need some parts. And if you have leftover parts after you use all your parts, save them. You may want to do mods. Eventually you'll end up with a bunch of bins. You're building multiple Vorons. Make YouTube videos. Put people to sleep. Hopefully not. You'll be asking people for subscribers and hit the like buttons. We'll be doing dad jokes. All right, so there's those screws there. Do this. A bunch of these. I need butts. Let's grab a bunch. There we go. All right. That one, and then they want one actually with this. Yep, they want one there. Okay, put this back in. And then they want one on the very end. I think there's a hole there. I think the hole's next. There we go. We'll look at that in a second, but just gonna pay these up so that they won't fall out. I strongly suggest you leave these guides or these stoppers in until you get to a point where nothing is going to take that rail off. Take them out early, like I said. You could be searching for a lot of ball bearings on the floor. But if you haven't done it, you should, because I think everybody should have to experience that at least once. So we're going to take our little snap guides, these little guys right here. Snap one on it right here. Oh, there. Snap one on right over here. And let's go back to the screen real quick. So we're going to do two like that. Midpoint, let's see, mind the axis hole position. We do know our best call out later assembly process. If in doubt, please refer to the CAD model. Might save considerable room downtime. The axis hole is the hole at the top that we noted when we saw it. Like I said, any tips, any little inklings of anything you see, you should be mindful of, because they admittedly, you know, that hole is right here, but it's not even in this drawing over here, even though they're mentioning it right here. So, yeah. And they mention right here, mind the carriage. Carriage is designed to slide along the rail easily. Unfortunately, this includes sliding off the rails. Dropping carriage likely irreparably damages it. That's because you lose the ball bearings that go into it, and it's no longer going to glide nicely. Let's put together the second one. Grab that. Process is the same. We already greased it up. Screws. All joking aside, I do appreciate anybody that does subscribe. If you do have questions, feel free to answer them. To date, I've answered every question, responded to every comment. You know, constructive criticism is always welcome. You know, nobody's perfect. If you do have opinions that are a little rough around the edges, send it away. But if you're just trying to be ignorant, keep it to yourself. Another thing I do is I do put in my description below some of the parts I use, links to some of the manufacturers or the vendors. I do use affiliate links with Amazon, so anything you do link or you click on below and you do make a purchase, it does help me out a little bit. Throws me a few pennies here and there, makes this a little bit more bearable, allows me to buy more things so I can make more videos. All right, so we got both of those. You notice the second one goes way easier because you already did it once. So let's get to this. Axis hole position, we just read that. So now we're showing this, and what they want us to do is using the centering guides, which are these guys right here, the black ones. Align the rails to the extrusion. Position the end of the rail 38 millimeters from the extrusion edge. Okay. This is when your calipers come back into play. So precision matters. It wants to be exactly 38. So we're going to pull this out to 38. I'm not going to give a lesson on calipers, but I will tell you this, that these measure in two directions. I am horrible at getting them exact, but so, I mean, if you're within 1,000th, 100th, probably pretty good. So this measures the distance between these as being, well, 37.99 right now, but the depth gauge that's on the end here measures the same thing. So this right here is equal to this right here, which is equal to 37.99, pretty close to 38. This is a set screw on the top. Get the number you want on there. You can set that. Like I said, I'm within 1/100th of a millimeter. I'm going to call that good. And then all I'm going to do is, based on the way that they show this with, again, this hole right here that I'm going to be mindful of because they told me to, and I know I should be, I'm going to measure my 38, my caliper, there. Okay. So I have that right there. So that's my 37, 38. I got my two centering pieces on there. So this right here is what I want. Okay. So after we do that, let's see what they're talking about here. During assembly, some rails won't be supported by stops to prevent carriage from coming off the rails. Some rails come with plastic stop pins. You can leave those in place for assembly. If those rails don't have these pins, leave the last screws slightly loose to act as a stopper. Alternatively, use some tape to fix the carriages in place. So ours have stoppers in them. But they're talking about leaving a screw slightly loose. I don't know if that would work here. The screws are going too far down. But you could tape it. I think if there's anything else I can think of that you can do to make it not slide off. Yeah, anyways, tape it or get some of these stoppers. Not all the rails come with them, but they are pretty universal if you have them from other rails. Go ahead and tighten these down now on this one. I think that might be a little bit too small. Why does that feel like it's slipping? Slightly bigger. Actually, you know what? They gave me tools. I just haven't used them. Another thing you're going to notice eventually is you're going to have so many Allen keys, wrenches, whatever you want to call them, that you're going to go nuts. You're not going to know what to do all of them. This one came with a little drill bit too. So that fits a little bit. Make sure we're still at our 38. 30. It actually says, no, this is 38 for a split second. Centered on the rail using our guides. We're at 38. These things was right. Tighten up one end, tighten up the other end. That. Decently tight now. Last one. I think, yeah. Yep. I'm gonna take these guys off. On one last time, double check, triple check. There we go. Again, we're gonna leave those little nubbies on there so we don't bounce right off. There we have a greased rail. That's all set. Let's do the second one. So again, we're going to slide these on. That. I'm going to line this up. There. Tighten one up. Where we want to be. 7.99. Now that we have one tightened up, should hold it in place while we tighten up the other ones. We'll still leave these guides on though. Go. Guides. Move them out. Not that. There are two in the middle. Here we go. Okay. Good. Probably should use Loctite on those. I will fix that off camera, but use Loctite on those. All right. One last measure. Good. All right. So they're showing us two end pieces there with M3 by 8 button head screws again. Get those. M3 by 8 button head screws. Let's see here. 3 by 8 button head screw. Then these are the guys I want. These little pieces that look like that. And we're going to put those on. We're going to be mindful of the fact that they are facing with the bevel end away from the rail and that they are going on the short end of the rail. Now, what they don't show is what they're screwing into. It's interesting, right? Yeah. They don't show that at all. So let's see if we have some bunch of ways I could do that. I don't know what they're expecting us to do though. Square nut. I've got M3 square nuts. I got some T-nuts somewheres. Oh, I saw some T-nuts. Yeah. I got M3 T-nuts. We got the square nuts. Or got these doohickeys they've printed. They're kind of like little nut holders. I'll hold an M3 nut in the center there so you can put them in, they won't slide around on you. So I'm going to use, if I can, one of my holders. Let's see if it's going to slide in there properly. Going to be enough room for that. Yes, there is. Okay. So we're going to grab two of those. I'll leave a link to the file for those as well down at the bottom. 1, 2, and then we just need some M3 nuts. M3 nuts. Get in 3 nuts. And 3 nuts. And not that it matters all that much this time, but Loctite. Blue stuff, not the red stuff. I use 2 different Loctites. I use this chapstick version. This guy right here. It's more of a paste. Works nice because it doesn't get everywheres. But it's kind of hard for small things. And as everybody's well aware of, the ThreadLocer Blue. So the way that these work, these little guys right here, is not actually sits right inside of them pretty tightly. And in there. Come on. Fingers are too big. There we go. That one. And in here for the other one. Yep. Let me show you what happens if you don't use anything like that. You're gonna put a nut in. It's gonna go in like, gonna slide right in there. It's gonna be fine. But it's going to slide around. See? Bob now, rail now. And so you're gonna wind up doing is grabbing a screw and trying to get in there and then moving it around. Then you're gonna try to get a screw, move around while you're holding something else. Use these. Going to slide right in like that. Put your piece on there, like it shows on the screen, and then attach them. So 3x8 button head screws is what we need now. And this time I will put a little on that. Don't need a lot. Parts are very small. Slide. Thought it was gonna slide. May not fit. I may not be able to use that. These might be too big for this. Running into the sticking out just a little bit further than they can. So I think what I'll do on this makes this one's pretty easy because they're right there at the end. We apply a little ThreadLocer on there. Going to pre-load this nut on this. I'm going to slide it in like that. It's another method, I guess, if you will. Tighten that down. And again, not bore everybody, I am going to go back in and put ThreadLocer on those. So you suggest that's something you do. More on there. So that's that one. And this one will do the same thing. One thing about building a printer like this is there's a lot of repetition. ThreadLocer on that. Load it. Probably don't need ThreadLocer on these pieces, but shame on me for forgetting the other ones. Oh. There we go. Boom and boom, right? Those two right there. So they are exact copies of each other. All right, what's next? C extrusions. All right, so they want us to do the same thing again on the C extrusions. Again, like I said, repetition, right? Get that. And A, B, C. So this was A, B. This is C. I got two of them. And how are we denoting these? So on their drawing, if we look really close, there's a little hole right there and right there. And that matches up with these guys that have little holes on either ends as well. Only those two holes, nothing on the other axis. All right, so we're going to do the same thing. We got our glide rails. We'll put those in. We're going to hold these in the same way they have them in the picture. So we know we're doing it right. We do know that these can go in either way now. They're just slightly a different hole pattern. Learn that. We're going to need two more rails. We'll grab two more rails. Yep. We'll have to lubricate these. Like that repetition we talked about, right? Now, you probably could get away without lubricating these rails, but this is like the best opportunity to do it. So it would be a missed opportunity if you did not do it. That's interesting. So this rail, a little bit of a feeling to it. I don't know if you can hear that. That's a normal rail. And then this one, that one sounds a little funny. So I want to clean that one. I wasn't expecting to have to clean a rail, but oh well, right? All right, let me grab alcohol. So I keep a little Tupperware dish with alcohol in it. And basically the first thing I'm going to do is wipe down the rail. Make sure there's nothing on the rail itself. Big or clunky. And then I'm basically just going to flush this. You can take these all apart, but usually overkill. It's already moving differently than it did before. So again, what I'm doing here, I'm utilizing the holes on the backside. I'm actually putting this pretty flush on there, and I'll say I'm pressure washing it, but I'm actually using some force to force the alcohol, the isopropyl alcohol, into the back of the rail there. Flush out anything that might be in there. Now, if you do clean these out, you do what I'm doing, just kind of a quick clean. They're going to get noisier and they're going to get funkier because we've now taken away all the lubrication that's inside of this. So it's metal on metal. And we don't want to leave it like that for a long time. One thing, we don't want to leave metal exposed to the environment. So any type of oil or grease on it. And we don't want the metal against metal for a long period of time either. Just because we'll get wear. Needs a in-between man in the form of grease. So we'll do. And usually what I'll do after that is I will take a little bit of a heat gun or some hot air of some sort. You don't want it really hot. You want it basically bearable to the skin. And kind of basically make sure you don't have any alcohol left in there. Because we use isopropyl, it will, you know, it'll just vanish here pretty quick. Basically want to get rid of our cleaning agent now that we're done cleaning. Okay. Okay. So let's go ahead and lubricate these now. Like we did the last time. PTFE lubricant. Put it over 2 holes. Basically going to insert it there. I'm going to put some pressure on there. Just wait till I start to see the grease just barely ticking out. That. I don't know if that's showing up on camera or not, but like that. Once I have that, I know that there's a fair amount of grease in the whole carriage at that point. So I'm going to wipe some of that off. That. Go. Let's get the other one. Same thing. Poke out. Fourth. Grease. And basically this excess grease that you're wiping on here, it's protecting the metal to some extent. You may want to put some light oil on this, some 3-in-1 or something at some point. That's up to you. I will say, do not put 3-in-1 oil on the or in the carriages. They will glide smoother and quicker and better and faster. But unless you want to relube your printer every time you use it, use a grease, not a 3-in-1 oil, or similar to that. Sewing machine oil, those types of things, they're going to fall out way too quick. All right, back to our screen. Where are we? We're doing that. We got these. We get them lined up properly, and we're going to start nailing these to the carriages. Okay, so just like we did before, we'll put those over like that. Only difference is this time we're going to actually use some ThreadLocer. Where's my little magnet? Moment. There. I'm going to do this. I'm not fussing with this forever. Put my magnet in the bag. Pull my magnet out of the bag. Get some buddies with them. All right. Then, when was it? All right. ThreadLocer on these. Like I said, at this point, it doesn't matter where this is lined up. You just want to basically get started. Rail is attached. Either end. That. moving. All right. Then again, these things are tapped a little bit differently than the way they say in the manual, but in actuality, that doesn't matter much as long as you have enough fasteners. Whoop, what? Catch myself there. I mean, didn't say anything. I didn't put any thread locker on those. I'm just trying to move quick enough so things keep moving. Honestly, these things take time. They do. Kind of like building a model airplane. You gotta find some pleasure in the actual building of it, or else you should just buy a machine comparable performance what you want. Nowhere's near as fun, and maybe a little screwed if you have to make repairs and you don't know how or you can't get the parts, but this is part of the hobby. It's just like anything other hobby. I mean, you can go in depth or you can go shallow. This is pretty in depth. People that go a lot further. I mean, just the Voron team themselves, they designed this stuff from scratch. So, all right, so we did that. We did this. I got one of those done. We're mindful of that. And this time they want us to go 33. Use the center lines of rails. 33 from the extrusion edge. Okay. So take that. I'm going to reset my caliper. Loosen that up. Turn it on. Zero it out. Bring it up to 33. Ah, 33.01, 32.99. So close. Come on. 33. On the money. Perfect. Ah, 32.99. It moved. Yeah. All right. Close enough. So let's see. 33 from the end. We're going to put our guides on this. Here. Here. There's just 30. 32.99. Right? Tap it right there. We're at 2.99 slash 33, right? And let's tighten up one of these screws just to hold ourselves in place. Yep, so good. That should be enough to hold that. Let's get the other side. That one. Okay. One last measurement here. Press these down. Even slide these up a little bit as I work them. But these extrusions, these rails are so short that there really shouldn't be much change in these. If you had really long rails, if you're making a completely different printer than this, you could even use 3 or 4 of those thinners. Use probably sufficient, but depends how far you want to take it. All right. Off. Go. One last measure here. Yep. And let's get to this one. Right here. ThreadLocer on that. catch. And another. There. Couple of these. Place. Place. That one. No. I need one more. Drop that one. A little bit. And really only want a couple threads at this point. Just enough so it's in there. It can go anywheres. Tighten them up too much right now, what's going to happen is when you go to slide your caliper to measure how far over it needs to go, you have difficulty doing that. So leave them loose. All right. See where we need to be with this. 32.99. So I can't get anything dead nuts on today, it seems. Whoop. Okay. There. Yes, we are. Slide this down on there. Tighten this one up. Move that over. And take care of these guys. All right. Doing that, let's look at this. All right, let's read a little bit here. No stoppers at this end yet. Mind the carriage. May want to use some sticky tape to prevent mishaps. So again, they're concerned about you losing your carriages. That's one of those things that you only do once, I guess, you know. But VORON team is trying to help you out. Rail positioning, we just did that. 33 to the end. Then this last message was to say, where's nut? The instructions won't call out nuts that were inserted in a previous step, nor nuts that can be easily inserted in the current step. So basically that jettisons you back to the other step where we put the accent piece on, and there's no call out for it. And they're admittedly saying it right now that they won't necessarily call those out. Which I agree, they won't necessarily call those out. So, all right, so we have the 33 on this end, it's the long end, and then they want those accent pieces on there again. Grab two more of the accent pieces, and we're going to need two more M3s with some nuts. That. Need to put a little thread locker on those. Reload these nuts. Oop. Okay. Reload these nuts. Grab them through here. Probably losing a little bit of thread locker on the plastic when I pass it through, but you only need a minute amount. jiggly. All right, there we go. All right, so these are gonna go on like so. That. Put it in backwards. It's gonna work too. Figure out how to tighten up that nut. That one tightened up. This one tightened up. There's that. All right, where does that leave us? Bed carrier. All right. So to try not to make these videos overly long, I'm going to stop there and go back. I'm going to put some ThreadLocer on those screws for the first rail I put on. Come back and have that all done. If you have any questions, any comments, or anything that you want to see, we've got a bunch of other content that's going to come in pretty soon. Like I said before, if you leave any comments, I do reply to all comments, at least currently. You know, I usually do it within the same day. So go ahead and like this video, subscribe if you haven't yet, leave me a comment, and we'll move on with the next video soon. Thanks for joining me.